And just like with the product rule, it would sure be nice if you were dividing two things, if you could just do the derivative of the top divided by the derivative of the bottom, and life would be easy. But that is not the case. The shortcut rule for dividing says, first of all, you keep, here we've got a top part and a bottom part. And the shortcut rule says, to find the derivative, you keep the bottom the same, multiply by the derivative of the top, then subtract, keep the top the same, and multiply by the derivative of the bottom. Can you see the top part of that is very close to your product rule? Product rule is adding, quotient rule has subtracting. Product rule doesn't matter what order you do, you keep the first one the same, derivative the second. Quotient rule, the order matters. You have to keep the bottom the same first. And then, on the bottom, you just keep the bottom the same and square it. This is your quotient rule. The same thing in Leibniz notation. You have a function on the top, you have a function on the bottom. You keep the bottom function the same, multiply by the derivative of the top. Then you keep the top function the same, multiply by the derivative of the bottom over the bottom squared. But very important in the quotient rule that we start with keeping the bottom the same. So whenever you get an equation, right, in our first example here, I have a quotient. My options are to use the quotient rule.
Sorry for the interruption, hopefully the last interruption for this. Last call for anyone who wants picture retakes or anyone who did not have their pictures already taken this year. So if anybody who wants picture retakes or did not have their picture taken this year, please go to the library. Thank you.
If you didn't have a picture taken, you have to get that done. Go to the library right now. And smile, bring a calculator. No, maybe not. Okay. So your options now are, is there any algebra you could do? Because sometimes you can do algebra and bring it into one of your other rules. If there isn't any algebra that you can do, well then you should use the quotient rule. And in this case, color coding stuff again. This is my function on the top. I want that in yellow. This is my function on the top. This is my function on the bottom. So the quotient rule says, keep the bottom the same. Keep the bottom the same. Multiply by the derivative of the top. Subtract. Now keep the top the same. And multiply by the derivative of the bottom. Over, rewrite the bottom and just square it. In most questions, you would be done. But this question does say, simplify your final answer. So what does that mean? I'm going to multiply out the top, factor if possible. So, in the bottom, I'm not going to multiply it out because it's factored. Simplified expressions in factored form is okay. And then factor the top, because if you factor it, it might show you that something could be canceled out. In this one, nothing cancels out. So this would be the simplified version in the end. So I'd like you to try using this new rule. Try to memorize the quotient rule. And in the next 3, you'll also have to practice all of your other shortcuts as they come up as well. I'll put the answers up in a bit. Okay, take out my highlighter. I have my function on the top. I have my function on the bottom. Quotient rule says keep the bottom the same. So first thing I do is I just rewrite the bottom. Keep the bottom the same. Then I do the derivative of the top, and here I have to use my shortcuts, right? The derivative of x squared, 2x. Derivative of 5x, 5. Derivative of negative 3 is 0 because it's a constant. Then I subtract and I keep the top the same. And now I have to do the derivative of the bottom. The derivative of 3x, 3. The derivative of negative 7x to the 4 comes out in front, making negative 28. Subtract 1 from the exponent. Over the bottom square. And personally, I'm going to leave it like that. I know that you could do the algebra. I have other boxes here. You could simplify this. But it doesn't say to simplify, so this would be perfect to leave your answer just like this. Ready for the next one? Okay, highlighters again. This is the top of my function. This is the bottom of my function. Quotient rule says keep the bottom the same. So I rewrite the bottom, the x squared minus 7. Then what's the derivative of the top? The derivative of 3 would be 0. And the derivative of 5e to the x would be 5e to the x. Minus, now I keep the top the same. This stays exactly the same. And I do the derivative of the bottom. Derivative of x squared is 2x. The derivative of the minus 7 would just be 0. Over the bottom squared. So we learned the shortcut, but a lot of the shortcut is just rewriting stuff. No work needed. And then you have to do a few little derivatives in the process to get the answer. Again, if you're like loving calculus, you can look up videos online of the actual proofs. They prove the product rule and the quotient rule with the definition of the derivative. So if you want to look that up, you can see how that works. Okay, third one. Here's my top function. I have a quotient. Here's the bottom one. My derivative rule would say I should keep the bottom the same. There it is. Kept the bottom the same. Now what's the derivative of the top? The derivative of 2 would be 0. The derivative of ln x is 1 over x, and I have a negative in front of it, so it's negative 1 over x. Minus, now I keep the top the same. Here's the top staying the same. And the derivative of the bottom is 5x to the 4 over the bottom squared. Now this is one that I will show you some simplification because it is a very favorite thing on multiple choice to simplify one like this. First of all, are you okay to see, oh, I didn't want to hit that box. Are you okay to see the bottom is an x to the 10? And what they want you to see in the top is you have, this is one term multiplied together, this is another term multiplied together. Do you see that these could be put together because you have an x to the 5 on the top and an x on the bottom? So I could just get that to be negative x to the 4. And then once I have those two terms, do you see that there's a common factor of x to the 4 in both of them? And if that common factor of x to the 4 is in both of them, you can simplify the x to the 4 and the x to the 10, giving you an x to the 6 on the bottom. This idea of factoring out a common factor shows up lots in the process of simplifying. And of course, where are you going to see that? In multiple choice questions. So I would say in multiple choice questions, derivatives are like mini identities. You do the rules and get this at step 1. And you're doing a multiple choice question. And you're like, yay, I got it. And you look at A, B, C, and D of your multiple choice, and none of them match. And now your question has turned into a little mini identity. What can I do with the equation that I have to manipulate it to hopefully get something that matches up in my multiple choice? So the multiple choice answer might have been negative 11 plus 5 ln x over x to the 6. And you're like, how do I do that? How do I manipulate it to make it work? You see that I took out the x to the 4, and then I also, in the same step, maybe I should have done this in 2 steps. Once that x to the 4 was out, I distributed the negative 5 to both of those. If you're wondering, like, how did I go from that step to that step? Could have shown an extra step there. Find the gradient or slope of the tangent to, and I'm like looking at this one and saying, hey, this is a quotient. I have something on the top and something on the bottom at x equals negative 1. And then we want to find the equation of the tangent line. So we remember, the key thing is, what is a derivative? The derivative finds an equation for the slope of every single tangent line on a graph at every value of x. That's what the derivative does. The derivative, all it is an equation for slopes. So it says, find the slope of the tangent at x equals negative 1. Well, if we use our new shortcut, because it's a quotient rule, what does our new shortcut say? We keep the bottom the same. Here's the bottom, I kept it the same. Then I multiply by the derivative of the top. Well, the top was x cubed, so the 3 comes out in front, subtract 1 from the exponent. Minus, now we keep the top the same. Multiply by the derivative of the bottom. Well, the derivative of x squared is 2x. The derivative of the 1 would just be plus 0. So this becomes 2x over the bottom squared. This equation is the equation of every slope of every tangent at every x value. Which slope are we looking for? We're looking for the specific one when x is minus 1. So now I just need to take my derivative, and wherever I have an x, plug in a minus 1 and do the mental math and simplify it, and I get a slope of 1. Next, we need to find the equation of the tangent line. What are the 2 things you need for an equation? You need the slope. Check. You also need a point. We don't have a point on our graph yet, but we can find one. We know that the x has to be negative 1. So if I plug negative 1 into the original equation, I get a point, negative 1, negative a half. I have my slope for my derivative, my point from my equation, and now I can either use y equals mx plus b, or I did y minus y1 equals mx minus x1. Rearrange this equation, and I have the equation of my tangent line. if y equals, and it looks like I definitely have a quotient rule here because I have something in the top over something in the bottom, show that the derivative looks like this. And then find all the values where it is undefined. So this, I'm going to put a box around this. This is like a multiple choice question. And on your exam, they'll say, find the derivative, and they'll write the derivative this way. And it would be one of your four choices. But when we do the derivative directly, to start off with, it's not going to look like that. In fact, how do we do our quotient rule? Right? Let's go through the steps again. We keep the bottom the same. So the bottom was x plus 2. I keep the bottom the same. I multiply by the derivative of the top. Well, the derivative of x squared is 2x. The derivative of minus 3x is minus 3. And the derivative of plus 1 would be 0. Subtract. Keep the top the same. So here's the top. Keep that the same. Multiply by the derivative of the bottom. Well, the derivative of x is 1. The derivative of 2 is 0. 1 plus 0, that's just 1. Over the bottom squared. So this was step 1. I just did my formula. Does it match up with what I want? No. Do some things look good? Do you see that your denominator is already good? The denominator I have is x plus 2 squared, and the denominator that I want is supposed to be x plus 2 squared. So this makes me think, all right, as far as simplifying, I should leave that the same. That's already done. What could I do on the top? Well, maybe I multiply things out and I combine like terms, and sure enough, once I multiply things out and combine like terms, everything matches up. When is something undefined? Something is undefined when you divide by 0. Or take a square root of a negative number. We have lots of places where things don't work. In this situation, it's only going to be dividing by 0 that's a problem. So it is undefined when x is equal to negative 2. We're going to get our tests back tomorrow. Okay? All I have left is to add them up and put them into the computer. And add your bonus. Better not forget that, right? Now, this is actually a rule I never memorize. You can memorize it if you want, the reciprocal rule, but watch what happens. Oh, not the right color. Watch what happens if I do the quotient rule instead. So if I want to find y prime, my quotient rule says keep the bottom the same multiplied by the derivative of the top. What is the derivative of 0? I mean, what's the derivative of 1?
0.
0. You guys are amazing. Minus, keep the top the same, well that's just a 1, and multiply by the derivative of the bottom, which is just the derivative of the bottom when I'm using this notation, over the bottom, all squared. Take my highlighter, right? What did we do? We kept the bottom the same, multiplied by the derivative of the top, kept the top the same, multiplied by the derivative of the bottom, and made the bottom square. Can you see that this just would go away because it's times by 0? Is it worth memorizing a whole new formula? I don't think so. Because it's just the other formula with a special case where the first thing is 0. personally wouldn't use this as a new rule. You're perfectly fine if you want to memorize one extra thing. You will have to memorize a lot of things this semester. So I find when you can shortcut one thing that you don't have to memorize, not necessarily a bad thing. Okay? So, if you wanted to find the derivative of this, for me personally, I would have normally just said this is my top, this is my bottom, and used my regular quotient rule. But if you want to use the shortcut, you could. You could just be like, I know that I can just do the derivative of the bottom over the bottom square. And with the bottom, this is my bottom, this is my g of x on the bottom. I probably would have written the derivative in that form there. In my work, I took the x to the negative half and moved it to a square root on the bottom. But I probably would have left it as a C in the blue box there. Because it follows your rules and you don't need to simplify. And again, if there's a multiple choice question, it could be simplified. So I'd like you to try the last one on your own with either the quotient rule or the reciprocal rule. You can choose either one. I will do the quotient rule first. I like that. Because you're going to know your quotient rule really, really well. You're only going to see this reciprocal rule once every 83 derivatives you have to do. I didn't just make that number up. There's a well-known statistic in that. In other words, the reciprocal rule is not going to come up very often. In fact, it happens so few times that if you'll probably take more time to think, oh, I think I remember this rule, but I don't. I would recommend just using your quotient. But, of course, right, all this does is puts a negative there. It does the derivative, it takes away the 1, while multiplying by 1 really isn't crazy. It gets rid of the 0 part right away. Okay, I'm going to give to you your next take-home quiz.